Good morning, students. Today we're going to look into Cyclone, a gas cleaning technology. Cyclones are used in solid gas separation. So, in fluidized bed, if there are particles that entrains, for example, in this case, so this is an example of a fluidized bed, and you can watch this in this YouTube link. So these are the entrained particles. Particles that escapes these fluidized beds. So these particles can actually be recovered through a gas cyclone. So this is the cyclone. This cyclone separates the particles and returns it to the fluidized bed. So it is also an important process in pneumatic conveying. So in pneumatic conveying, air or gas is used to transport solids from one point to another. So once it has reached the point, then we have to separate the gas at the end of the transport line and collect the solid particles. So for example, like this one, so this is the end of the pneumatic transport. So at the end of the pneumatic transport, it reaches a cyclone, and this cyclone will collect the particles that is required through a cyclone and then down to a hopper, and then the gas will be the gas or air will be released or reused for pneumatic transport. Solid gas separation is also used in combustion. Okay, so for example, this one where combustion takes place. So this combustion, this burning process will carry hot air and some fine particles, fine dust. So what do? It goes through cyclones. It goes through cyclone to separate the escaping dust and release the hot air. So that's where we use this gas cyclone for solid and gas separation. Cyclones are used for relatively large particles, and these cyclones, this is an example of a cyclone, usually consists of a cylindrical part here, a shell, and then it has got a conical base and a dust hopper at the bottom, and it has got an inlet for the dirty gas plus particles to enter, and then it has got an outlet where the clean gas exits, and then this is where below the hopper is the exit for the particles that has been collected. So these cyclones cannot be used on its own. I mean, it cannot be the only cleaning agent. It's actually insufficient to meet the stringent emission standard. So it acts as a pre-cleaner. So it is a pre-cleaner to remove bigger particle size, and after that, further cleaning needs to be done using other separation mechanism. So this is a graph for, it's a typical efficiency curves for different gas solid separators. So as you can see, cyclones are efficient for bigger particle size, more like it's bigger than 1 or bigger than 10. Bigger than 10 cyclones are better. Okay, so for smaller particle sizes, we can use wet separator, electrostatic precipitator, or much smaller is the filter. Filters we covered in the packed bed chapter in this course. So these two, if you're curious to know how it works, you can actually look at the YouTube link given below. So that will give you what are these separators. So usually, if let's say the particles are bigger than 100 micrometer, we just use gravity settling for the bigger particles to settle down. And if it is less than 10 micrometer, then we require energy intensive method such as these three. Okay, so gas cyclones we can use for a bigger particle around this range, even 10 to 100. We can still use for one, but then we just have to make it, we have to design the cyclones for higher efficiency. To achieve 50, yeah, we need about 10 micrometer. So gas cyclones are not suitable for suspension with large proportion of particles less than 10 micrometers. So there's too much of this size of particles, so gas cyclones will not do so well. So if you notice, the efficiency hardly even reaches 50%. It's not even 50% for the ones below 10 micrometer. Okay. So let's look into the cyclone mechanism. So cyclone operates on a principle that the aerosol material, or the particles, the fine particles or the dust materials in the carrying gas stream has greater inertia than the gas. So the particles has greater inertia. So this is how the particles will enter. This is the dirty gas inlet. So it is expected to spiral downwards in this motion. Okay, so if you can see, it's actually as in the right-handed down, and then as the particles spiral down, it is expected to hit the walls of the cyclone and then slide down to the bottom to be collected. And the gas, once it hits the bottom of the cyclone, will spiral upwards in a reverse direction and leave the cyclone. Okay, so this is the pathway of the particles. It hits the wall and it follows the wall direction, whereas this is the pathway of the gas, where it is directed like a cylinder. Here I have shared two YouTube links for you to watch, so you can watch how two different types, slightly different types of cyclones works, where the particles spirals downwards and the gas is the clean gas exits at the top of the